Hello, everyone, and thank you for joining this session. My name is Gonzalo, and I will present our paper, Lessons Learned Surveying the Practicality of Differential Privacy in the Industry. A quick disclaimer, the information and views set out in this article are those of the authors and do not necessarily reflect the official opinion of the institutions. So let me give you some context for the research of this paper. It is focused on differential privacy, and as we know, it was introduced in 2006, and it has become a predominant statistical privacy tool. So, sorry, wait a second. Thank you. All right. Sorry for that. It was obscuring the text. This paper is about differential privacy, which was introduced in 2006. And since then, it has become a predominant statistical tool for quantifying data privacy in academic works. However, despite all this momentum that it has had in research, differential privacy has failed to achieve widespread adoption in the enterprise domain. So we have multiple tools that are open source, and to some extent in research, they are easy to use. However, when we try to deploy them in practice, it seems complicated. And only a few companies, amongst them the big tech ones, have real differential privacy deployments in the industry, and the rest of the companies, which are in the thousands and thousands, are not using differential privacy. So there is a gap, and this is what we wanted to tackle in this paper. If you really summarize it and abstract it a lot, we aim to answer, does DP make sense in practice? And if so, when? This is an oversimplification, but it's just to grab your attention during this presentation. Okay, so first I will introduce differential privacy. It is a formal privacy guarantee that quantifies privacy, and it bounds how much new information an attacker learns from observing a new data point. If we define it formally, you can see the definition on the screen. And this essentially means that if an algorithm fulfills differential privacy, that means that the outputs are essentially the same, whether or not an individual is in the data set or not. And we can give a degree of the privacy protection of an analysis depending on the value of epsilon, which is also considered the privacy budget. So you can adjust it depending on your privacy needs. So for the scope and research method of this publication, I have to say that we focus on practitioners performing data analysis internally. That means that the data and the analysis did not leave the company. It was all internal. And also we focus on the central model of differential privacy, which typically adds noise to aggregate data versus the local model where you typically add noise to individual data points. We interviewed 24 practitioners across 9 major organizations that have not deployed differential privacy. This is because we want to focus on the majority of companies in the world that actually maybe don't know or have not deployed differential privacy, and it is only when they do that differential privacy will become widespread. Amongst these major organizations, there are even companies that have more than 100,000 employees. We had 24 practitioners, amongst which 19 were data analysts and 5 were data stewards, and we asked them 24 questions that we gather under 5 research questions. I will give in the beginning some general insights from the interviews. The paper is very verbose, it has many insights, and it's very hard to put all of them in a presentation, so I had to select the ones that I think are most interesting. So here you see a typical flow that these companies shared, and it's a commonality between them. First, the business unit requests a use case from the analysts to look into. The analysts will explore data sets to see which one is the most fitting one for the use case. And then they will request access to the one that they think it's best. This data access request actually takes a lot of time sometimes. It could take a couple of months if it's new, or it could take days. And it is a big bottleneck for many. But once they have access, they will inspect the data visually. So they will check the data points within the data set, and they will pre-process data so that they can analyze it and then interpret the outputs and deploy the solution. So this seems very easy to understand and is very common, but it will become relevant in the next of the presentation. Something that I found interesting is that I got to see what is the current anonymization in the industry. So they have usually 2 types of use cases, primary and secondary. In the primary ones, it is the ones that they collect data for what they ask the users for. So for example, I allow you to collect the data for analyzing this in particular. So those are primary use cases that don't need anonymization, and they have the secondary purpose use cases where they would anonymize the data, and because it's not personal anymore according to them, they could use it for other purposes. The anonymization they use is based on factual anonymity, which is basically an heuristic that tells you that you should make re-identification so costly that doesn't compensate the benefits of re-identifying someone. And also they use proportionality in the sense that they would only collect what is strictly necessary. Some of the techniques they used are suppression, generalization, they would drop outliers, etc., which are very good and complementary to differential privacy, but they're not good enough because it's shown in academia that in the past this has been broken, also in practice. And I think there is a need for stronger privacy guarantees used in the industry and not only to suppressing identifiers, for example. Now, I will go through some of the most interesting results under the research questions. And we start with what is the context of privacy protection. So I saw that many of the companies were more invested in security than in privacy enhanced analytics. This could also be because these analytics tools are not as mature as others. And at the same time, they see privacy as an asset. Quality has to be equal to the premium product offer. This is an insight that I found interesting. And also what was lacking is a metric that could measure how private something was, right? And they were unable to give me a tangible answer. So if you even with this factual anonymity heuristic they had, they couldn't give me a number. And I think differential privacy could play a role here. And also something that is very privacy forward is to analyze data without actually having access to the data set. So you cannot see the data points, but they said that they were pretty far on average from actually deploying this type of analytics tools. Also, I saw that there are two main pain points on this workflow that I showed you before where differential privacy could help. As we know, the anonymization techniques that I showed you were not, they don't offer strong privacy guarantees. And the process to request access to data is very long, and it partly is because they don't have a strong guarantee, right? So potentially differential privacy could shorten these request processes because you would offer a stronger guarantee. So therefore, the process to request data should not be so onerous, should not be so strict. And also something that is interesting is at the end of the process where once you get access to data, only policy protects it. There are very few restrictions of the analyst to download the data locally and then export it to another external drive or take pictures of the data, for example. So there is, at some point, only policy protects it, and differential privacy could add that layer that is missing. Also, we know that differential privacy is not a silver bullet. So in terms of quality, safety, and fairness use cases, differential privacy could maybe harm the users rather than help them. I'm sure if there are enough data points, this wouldn't be the case, but I think we should have careful consideration of these use cases. And also something that I found interesting is that most of the researchers on average agree that 98% accuracy is something that they would be comfortable with. And none of them said something below 90. So people are not used to working with noise. And this is something that some of them actually don't fear, because in some companies, you actually get a bonus if you are right in your analysis. And if you add noise, you might not be right in some cases, right? So this is something that maybe should change in the philosophy of some companies. But at the same time, it's something to consider, and that users are not used to, analysts are not used to working with noise, and they claim they want high accuracy. Lastly, I think differential privacy, based on what I saw, could enable exploration of sensitive datasets. Some of the datasets were not even accessible, and after you go through all the process, so perhaps exploring them beforehand is useful, so that you don't have to go through a process that in the end is fruitless. And also I checked whether SQL was important for them, which it was more important than ML. And then I also checked what are the SQL queries that they used, and all of them are amenable with differential privacy. So it could actually have an impact in their analysis, daily analysis. So some of the selected key findings, acting as a summary, we see that differential privacy could have a significant impact on dataset exploration, could actually fulfill certain use cases that you will see in the next slide. Analysts are frequently blocked for significant periods of every time they request access to datasets. And we saw that most analysis employ aggregations and visualizations to fulfill their use cases. And machine learning was not predominant, actually, on the average company. So now we see that does it make sense? It often makes sense on dataset exploration. It could help in dataset access request processes, and sometimes in that analysis, in the final one, it could also help. For example, if you are doing user behavior analysis or demographics analysis or some location-based analysis, if you have enough data and depending on your deterministic function, actually the analysis could be carried out with differential privacy in these companies, whereas other use cases that I mentioned before in terms of quality or fairness or security are not amenable with using differential privacy. So based on all the interviews that I conducted, all the things that I learned, and all the analysis that I did on the private open source privacy tools that are available today, I came up with a set of 10 key functional requirements that these differential privacy tools should have so that they are more deployable in practice. Obviously, the first one is they should enable DP analytics, but also it's very important usability. Users will not use something that is not easy to use, and also features are very important rather than maybe the accuracy of a query. But if you have the features that your company needs, it's more likely that they will deploy it. There is also many aspects in security that these DP tools should fulfill. They should support stochastic testers to make sure that the differential privacy algorithms are actually differential private. And also there are topics on this. Synthetic data generation will be very useful, and visualizations as well. We have to also consider in the design of these tools the privacy budget, because you should curtail at some point the privacy budget when an analyst exceeds it. And also entering an accuracy adjustment in the beginning instead of an epsilon would also benefit many analysts. And other two principles in the last two principles that are helpful when you want to integrate it with legacy systems at a company. And then I mapped the principles and the properties of these tools, and I outlined the gaps that are today in these open source tools that I hope that privacy library developers and framework developers look at and improve their tools. And in summary, does DP make sense in practice? Yes, sometimes. And if so, when? Well, I see that often for data set exploration, differential privacy can help a lot analysts in companies. Some non-critical aggregation use cases, as we saw, could be fulfilled ultimately by differential privacy, and potentially it may reduce access times to data. Thank you, and I'm very happy to take questions.
Thank you for the talk. We have a couple of questions on Zulip. The first two from Dan and Marco are related about, can you give us a bit of more information about the 9 types organizations that you surveyed, and what are their types? Are they big? Are they small? Are they EU, non-EU? Some more information if you can.
So there is also sorry that the audio feed is not so good, so it's hard to understand the question. But nonetheless, I think I got it. There is a table on the paper in the appendix that shows you the characteristics of these companies. Some of the companies have above 100,000 employees. Other ones have like 10,000, and other ones have less than 2,000. Most of them were based on the EU. A few were based in the US, and they all had data analysts, and data was very, very important for them. And they were from different industry domains. Some of them were from the automotive industry, other ones from the insurance industry, others ones were on data management tools. So the spread was varied, and you can find that information in the appendix.
Thank you. And another question from Teresa, she's asking, you implied that DP would be a way to measure privacy. Did you ask these practitioners whether they could work with DP as a privacy definition in practice? Would it suit their needs?
I couldn't quite get the question. Perhaps you can type it on the chat. But is it that did the practitioners work with differential privacy before? Was that the question?
No. Is it more like the definition of differential privacy if it suits their privacy goals as a definition? Like, could they use it as a privacy definition or not?
It is very hard to understand the question.
Okay.
I didn't get it. I'm sorry. The audio is poor. Yes, okay. Okay, great. Thanks. Much appreciated. I apologize. So I think the value of epsilon is very abstract for analysts that are not familiar with differential privacy. So telling them to choose epsilon might not necessarily be good. Nonetheless, I think the metric of accuracy, if you ask them, hey, what level of accuracy would you like to have on your analysis, I think that would be more useful and more tangible. And with respect to the question of whether or not this is useful, it is useful to give this metric, but perhaps not epsilon, but rather an accuracy metric.
Okay, let's thank the speaker again. Thank you.